This is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. Today, we bring you news that researchers have succeeded in making 17.4 precipitation hardened steel powder bed fusion. This is a fully martensitic 17.4 pH steel. So this has a needle-like structure, martensitic-like structure, which makes it extremely hard steel, similar to if it was quenched repeatedly in a kind of traditional process. And this material has similar properties to wrought steel, precipitation hardened steels with the same characteristics. The way they've done this is almost more interesting than the news itself. There have been some work on this before in characterizing alloys and developing them for 3D printing using the advanced photon source, which is at the Argonne National Lab. It's a synchrotron. It has an X-ray diffraction tool on it. And what they do is they look at the individual particles or the powder of the steel as it heats and is cooled by the 3D printing process. And then they use this to determine the right makeup of the alloy and also the right settings for the 3D printer. This, in this case, has led to a 17.4, which is reliable and reproducible. And that's what the team published in their article, which is called Phase Transformation Dynamics Guided Alloy Development for Additive Manufacturing. And I think that's the broader point here by Keelan Guo and the other people at the Department of Mechanical Engineering at University of Wisconsin-Madison, because this guided alloy development is something that has been used before and can be used much more often. Of course, this light source is going to be quite an expensive thing to kind of borrow in order to do this research on. But apart from that, it could be used more often to develop exactly the right settings, exactly the right alloys for printing and printability. This could be a very, very exciting kind of approach to us to getting more of these materials made and more of these materials in our hands. So this is a really, really good development. Next is the Creality Ender 5 S1. This is a $599 printer. It shows that Creality is moving up in price and moving towards the mid segment, kind of like they're usually like what used to be the $1,200, $1,500 printers. And this printer has a 2 Z-axis linear shaft system. They've also done things like, for example, they've done testing that they claim shows that they have a 100% success rate for 1,000 hours of printing in some of the test beds they've been doing. So it's nice to know that they're doing this kind of testing. And it's also interesting that they're claiming this kind of testing. There's a lot more kind of substantive information, substantive claims here in Creality's work, where they're really saying, look, trust us, this is what we're able to do. Also, they've got an all-metal Sprite direct extruder head that they've developed in order to extrude just regular materials, also flexible materials, also materials like ASA or ASA, which I think is one of my favorite materials. They've also got Urus air ducts. So notice the Sprite direct extruder head at Urus air ducts. So they're branding things as well, which I think is a way forward as well for players in the 3D printing space to really brand certain components to really kind of get people to believe in them and to buy the printer. So I like that about the print head and also about the air ducts. So these Urus air ducts are mounted on the nozzle, and the idea is that they're going to improve performance by generating the fan ducted air to the right point. I really think that this is something that should be done a lot more often, a lot more precisely, because that could really, really improve our print results. It's got a polycarbonate detachable print sheet. It's got auto leveling. It's also got, and I think this is really nice, it's got like a lot of reduced clutter, and it's kind of like managed to work away a lot of the wiring throughout the printer and also on the bottom parts and all that. And it's got more higher quality plugs. So a lot of that is really nice. I think actually, by the way, this looks really nice to me. I really didn't like, well, at one point everything looked exactly the same. This to me is a nice looking printer. It's got optional Wi-Fi on it, not standard. And there's just a lot to like here. I mean, I really like these improvements seem sensible. It seems like the kind of things that you would want on a printer. And if we're going to make a lot more systems like this on the $600 price point, but a lot more sensible features in it and a lot more stability in the platform, stability in a kind of a more higher quality chassis kind of component. I really like this. I think this is a good development for the market. In this, if we're going to have a nice little $600 segment that takes a lot of the features that we used to have at $1,200 and makes some $600 printers with those same features, I'm all for it. I think this is a great development. The next thing is that NASA, together with space kind of conglomerate, kind of fruit roll-up or roll-up company, Redwire, which is buying a bunch of space supplier companies in order to integrate them, together with the Uniformed Services University of the Health Sciences Center for Biotechnology, are sending a new 3D printer to the International Space Station, or a new one. It's the Redwire Biofabrication Facility, which is initially the Tech Shop printer, which you've written about at 3dprint.com a lot. Now, what they're doing now is they're sending this thing up on, or they're sending it on November 6th up from NASA's Wallops Island Center, and they're going to use it to try to 3D print a meniscus in space. So there's two reasons why, there's many reasons actually why bioprinting in space is of particular interest, but one of them is, of course, well, if an astronaut gets hurt 2 years from the nearest space station or Earth, how is she going to repair herself, or how's her team going to help her get better? Well, there's not that many options at one point. So bioprinting in a really, really ultra long space missions could really be a necessity. Also, well, the second reason is really that, the bioprinting capability could maybe help these guys, mitigate any kind of unforeseen problems as well. Maybe that capability is not going to be used to bioprint a part for an astronaut, but maybe it's going to be used to bioprint some kind of new filter that they need because their filtration system unexpectedly failed or something like that. So it's kind of like the idea to improvise is another good reason to work on this technology. But the third reason is not discussed or thought about as much, and that is that, well, maybe it's difficult to 3D print a meniscus on Earth, and it's much easier to 3D print said meniscus in space. So maybe we get a better meniscus, we get a better result if we print heart cells. Maybe the heart has a higher accuracy. I don't know what. So there's a lot to like here in this news item, and I think it's exciting that these bioprinting and space experiments continue. There's a couple other people working on it as well. And it's also exciting to see that Redwire is continuing to kind of be this conglomerate that is trying to push the edge and be kind of a supplier on several different fronts, including several additive manufacturing fronts, to NASA and other space companies. I think that's a hell of a development that you see these companies that are trying to be like a one-stop shop for a lot of the components, parts, and services that other space companies need in order to accelerate their development. I think that's a really great development. And that's it for today, guys. So thank you so much. My name is Joris Peels, and this is another edition of 3D Printing Unpeeled. Have a great day.